you ready for the vacuum special?
The Hyneman abhors a vacuum.
Oh, Jamie, I know how much you love riddles, and so it's riddle time. Here goes. What sucks but does not suck?
Vacuums.
That's right. How did you know that so fast?
We just did that opener with model trains and a vacuum cleaner.
Fair enough. Okay, this is a story that has been on our books since literally we started collecting myths. We've just never tackled it because it always seemed like it was too big for us to tackle.
Just get on with it.
All right, it involves something that's the opposite of one of our favorite things. The opposite of an explosion is an implosion.
Go on.
All right, there's a guy. He's tasked with cleaning out one of those tanker cars on a train that holds liquid, and he's using a steam cleaner. So he's steam cleaning the whole thing, and of course, as he's doing that, he's warming it up. And it starts to rain. So he caps off the tanker car and walks away. The cooling rain causes the steam to contract, and as the myth goes, the train car crushes itself.
From a vacuum.
Exactly.
That is big. Those train cars they're huge.
I know.
After more than a decade of detonations, totaling over 900 explosions, for the first time, the Mythbusters are tackling an implosion. And to do justice to this impressive long-running record,
This is gonna be cool.
they'll be focusing an entire episode on this one supersized story.
I mean, look at this. It's going to be the biggest productions we've ever undertaken on this show.
Causing vacuum violence on a massive, unprecedented scale.
It's gotta go!
But first, some shop-sized science.
An imploding tanker car. How could this happen? Tanker cars are giant, 70 feet long, 15 feet high, thick steel casing meant to contain things like fuel, even in case of a derailment. How could something like that spontaneously implode and crush itself? Well, if it did, in fact, happen, it had to do with pressure and pressure differential. I'm getting ahead of myself. Let me show you with this metal can. If I take this thin metal can and seal it, and then hook a vacuum pump up to it and start pumping air out, we understand what will happen. It will crush itself. Whoops. But how could something like that happen without the action of an outside vacuum pump? Well, let me show you. Now, I'm about to perform a critical action in this experiment, and that is to take a little bit of the hot water and pour it into the can. Because in the original myth, the tanker car had been steam cleaned inside and out. Now, I'm about to initiate an implosion. First thing I do is cap the can. Now, fully capped, this vessel was full of steam and air that was heated to its boiling point. Now, that air is rapidly cooling. As it's cooling, they're creating a negative pressure inside the can.
Yep, and that's the whole ballgame. A difference in pressure. Filling the container with steam pushes out the air. But if the vessel is sealed while it's still hot, and then allowed to cool, the steam condenses, and the internal pressure drops, meaning the now much greater external pressure pushes in on the surface. And that's bad news for the can.
Oh, there we go. There we go. Oh, it's actively moving. Look at that. I'm doing this with my mind. In case you were wondering, this is all telekinesis.
Mind games aside, the scientific principle is clearly sound. Now, it's just a question of scale. Can steam cleaning produce a pressure differential that would cause a giant steel train tank to crush?
The two sides have actually met over here.
To answer that, Adam and Jamie will learn as much as they can and slowly build up to the industrial-sized mythical implosion.
Yep, it's generating some steam.
But first, does faster cooling make a difference?
Go. Burner off. Now, I want you to cool, and I want you to cool rapidly. I'm gonna use the coldest thing I know, and that is a CO2 fire extinguisher. Here we go. That was much more spectacular. Look at that. So there you have it, a little proof of concept of how a sealed vessel can crush itself with just the application of a little heat and a little cold. That sound, if ants had a Latin rhythm section, that's what it would sound like. But it's a very different thing to crush a flimsy metal can versus something meant to hold pressure and meant to be very durable. And I think I've got just the thing to experiment on.
We're going to ramp things up quite a bit to this 55-gallon drum, which not only has steel walls that are many times thicker, but also structurally it's much stronger because it's round and it's got these ribs. So it'll present much more of a challenge.
All right, now we just wait for it to boil.
For this first test, we're just going to heat the water up until it's boiling vigorously. Then we'll seal it up, turn off the heat, let it cool, stand back and see what happens.
Sealing it up. There we go.
Now that it's sealed, a pressure differential can develop, and the wait begins for the steam to cool and condense.
That kind of makes me nervous.
If this sturdy steel barrel collapses, confidence will be high that the full-scale tank car can also crumple.
How long did it take the little cans to crush?
Those crushed very, very quickly.
I'd imagine they're not structurally near as strong.
No. I think it's going to be one big catastrophic kind of thunk. It's going to sound like hitting it with a baseball bat. Oh! What's really cool about this is we heard a couple of bings and bunks at the beginning. This is killing me. But right now, this thing hasn't made any noise in 15 minutes. But what I know is happening inside there is that it's cooling, and that steam is reverting back to water, and it's creating low pressure in there, which is pulling the sides in. They're resisting that because of their structural integrity, but at a certain point, I expect the outside casing to fail, and it should be pretty spectacular. Next time we hold the camera up with magnet. Whoa!
There you go.
Wow!
You can feel that.
Woo! That was so cool.
I could feel that in my chest.
Yeah, well,
which
I'm
is
not
weird.
sure if that's just my heart leaping out of my throat because of the... That was amazing.
It was a nerve-shredding display of power. When water vapor is cooled, it can cause a strong steel drum to completely crumple.
Wow.
Made a circle into a triangle.
It did.
There's clearly a lot of potential in this one simple process.
Wow!
And an ominous sign of the full-scale potential. But Adam isn't ready to move on. Before they can tackle the supersized tank car, he wants to know exactly how much negative pressure they're dealing with.
This time we're going to do the same test again, but we're going to have a vacuum pressure gauge attached so that we can actually monitor what that pressure is. We will also be timing how long it takes to cool down and monitoring the temperature with an external thermocouple. That's a fancy way of saying thermometer. All right, it's bouncing between 193, 195. We'll be logging all of this data as this thing cools down, builds its negative pressure. Okay, timing starts now. And the vacuum gauge is already moving. That's awesome. And eventually crushes, in the hopes that we'll be able to apply what we learn here to a full-size thing eventually.
Yep, and because
The only difference between screwing around and science is writing it down.
Adam plots the increase in negative pressure measured in mercury
So right now it's just at 3 inches of mercury,
against time and temperature.
6 inches Hg.
How much of a vacuum will crush the can is unknown. But quantifying the failure point is the first step to understanding the process.
Look, we're not exactly sure what we're looking for in this. We're just trying to get to understand the process. So very consistent 2.5 degrees per minute. I like linear data.
I'm partial to exponential curves myself.
So the more data we gather from this as it cools down and eventually crumples, the better equipped we are to deal with contingencies out there in the field. Oh! Whoa! That was just at 16 inches of mercury.
It's interesting that they're consistently forming triangles, but it kind of makes sense because it's the strongest form that it could crush to. These implosions are fascinating. There's a slow, intense buildup of the pressure differential, and with no warning. But what did we learn? Well, it took 8 minutes for the steam to cool, which dropped the pressure to minus 16 inches of mercury. Considering that 30 inches of mercury is a full vacuum, that's significant.
Cool sounds.
And that's just from heating a little water in the drum. What happens when we introduce a high-powered steam cleaner into the equation?
Temperature's climbing fast.
Coming up on Mythbusters.
That is awesome.
Not only is this
Without a doubt, one of my favorite small-scale experiments we've ever done. Oh!
the story is on track to be the biggest logistical challenge they've ever tackled.
Holy
Pressure vessels and pressure differential are familiar themes the Mythbusters hold dear to their physics-loving hearts. And in this one-story episode, they're investigating a monumental implosion.
This is gonna be cool.
Can condensing steam really cause a supersized freight train tank car to crush?
Oh! Wow!
This is great. We are gathering data, we're learning stuff, we're moving forward. Oh! Whoa! 16 inches of mercury. But the most important part about this right now is that the original tanker truck had apparently been steam cleaned prior to the implosion incident. Therefore, we're gonna move on to another 55-gallon drum, but this time we're dispensing with the burner and the boiling water, and we're gonna steam clean it in advance.
Okay, here we go.
Go for it.
We're gonna try and get its temperature up
150.
and a lot of steam in there before we cap it and see if we can initiate another crushing incident.
170. Temperature's climbing fast.
Will the high-pressure steam cleaner make a difference?
All right. Sealing at 203.
It seems so. This crucial component of the mythical mishap has raised the starting temperature by 10 degrees. Consequently, it's taking longer for the steam to cool and condense,
So much tension.
and the negative pressure to build.
16 minutes. Whoa!
Ooh. That gets you every time.
Whew, that is a heck of a rush. That was 17 and a half.
There was a greater pressure differential.
Oh, yeah.
It took twice as long to implode. And appeared more violent.
It's actually collapsing a lot more than the other one did.
I think we put more energy in the system with a higher temperature and the steam.
Yep, more heat means the steam has more kinetic energy, and faster water molecules create more pressure.
Yeah, look at that. Look at that. That is completely crushed.
So when the steam condensed in the capped container, the eventual pressure differential was greater. And the drum took even more of a beating.
If you fill one of these 55-gallon drums with water, they weigh over 400 pounds, so they're really quite strong. But in the presence of the vacuum, the way that we're applying it, they crumple like a soda can in your hands. So it gives you an idea of what kind of forces are at play here.
Here, check this out. That's the previous test. That's the current test. See how much smaller this one was crushed? It's a lot more energy. That was awesome. Can I say it? That was a barrel of fun. Actually, by the time we were done, I'd say it was about a third of a barrel. Here's what I feel like we have learned so far. We have learned that a higher starting temperature equals a more vigorous reaction. Clearly, when we go to full scale on this, we're gonna want the highest possible starting temperature, and that might be maybe the most difficult part of replicating this story.
But behind the scenes, problems are afoot.
Okay, keep very quiet. We don't often show you this part of the show, but this is where the magic happens. This is our production office, and those are our producers that find the impossible to find stuff that Jamie and I need to use in episodes. This is the team that has found us things like a 747, RPGs, or calling the FAA to get us permission to drop a car from a helicopter. But right now, this might very well be Mission Implosion impossible, but we'll give them a couple more days. So what is it we need exactly? Well, obviously a tank car, one that's been decommissioned and yet is still structurally sound. That's hard enough, but we also need a place to implode it. That implies tracks to run it on and a location remote enough that we can safely control that implosion involving millions of pounds of force and thousands of pounds of steel without hurting any people or infrastructure. And the two of those together are the reason we have never tackled this myth before.
With the production office facing long odds and a short deadline, Jamie and Adam get busy drumming up more data.
So what else can these barrels tell us that'll help us out in the field? Well, shape and geometry are critical when it comes to pressure vessels. And so we're going to build a more accurate scale version of our tank car cylinder and see what difference that makes.
Will the elongated cylinder of an accurately scaled tank car crush more or less easily? To find out, Jamie has been busy welding while Adam whips up some wooden wheels.
Almost there.
And gets back to his special effects roots.
Ooh, there we go.
I'm much happier when our experiments look the part.
Awesome. Moving ever closer to our goal of causing a fatal catastrophic implosion of a full-size tanker car, we have now built ourselves a scale tanker car. 4 55-gallon steel drums welded and sealed together. We're gonna hit it with a steam cleaner, bring the temperature up, cap it, and see how long it takes to implode and what we can learn from that. This is a very cool scale experiment.
As before, they simulate the steam cleaning process.
Great for our skin.
Until the temperature maxes out.
200.
Then they seal it up
All right, capping it up.
and resume their nerve-wracking wait.
Timer's going. Oh, hey! Oh, you can hear it boiling.
Oh,
You can totally hear it boiling. That's awesome.
I can't help but think that this would be weaker because of the lack of any bulkheads down the length of it.
Okay. 7 minutes in, we're at 11 inches of mercury. It's gonna be like a big steel set of hands clapping.
Yeah. It might well, you know, macaroni there, but
That would be so awesome. Oh, that was fantastic! Woo! Oh, that was fabulous! That is awesome! You were right, it was weaker. It failed at a lower negative pressure than the previous one.
Another spectacular implosion. The accurately scaled form failed faster and under less pressure.
That's just awesome.
Data that suggests this supersized myth is right on track.
That was awesome. I guess all we need now is a full-size tanker car.
Yeah, that'll be interesting seeing that happen to something 70 feet long,
That would be a hell of a thud.
if it happens.
Yeah. All right, let's go find one.
For over a decade, the Mythbusters have traveled to incredible and expansive locations to carry out their investigations.
Good to see you. Welcome to the White House.
They've managed supersized logistical operations of massive proportions.
Ladies and gentlemen, 70,000 feet.
But in this extended, in-depth story, they're tackling the toughest of them all. Welcome to Oregon, the end of the line for the tall tale of the imploding tank car. After months of prep, sweat, and fears, the team has pulled it off. It's time to stock and roll.
If it is indeed possible for a tank car to crush itself, well, then the testing of it is going to be one of the biggest productions we've ever undertaken on this show. That is the biggest steam cleaner you have ever seen. We need not only the tank car and some train tracks, because that's how they get around, but we also need a facility where we can shut down access to those tracks for safety. Let's get to crushing.
There's no doubt about the size of the undertaking. And the first piece of this giant experimental pressure puzzle is bringing the heat.
This boiler is the heart of our experiment. This is a 2 million BTU fire tube style boiler. Now, what's in here is a series of tubes surrounded with water, and obviously is going to heat up that water, and it's going to create a head of steam that comes up about here. And that steam is going to be up to around 360 degrees Fahrenheit. That's what's going to heat up our tank car.
And here's why the steamer is packing so much punch.
Gonna go get some tank cars.
It was almost impossible to locate. But in a coupling made in geek heaven, Adam hooks up with the supersized star of the show.
I totally get the whole thing about model trains.
How cool is that?
I had a whole bunch when I was in high school. Hello, ladies.
This is our experimental baby, our tank car. Isn't it beautiful? 67 feet long, 10 feet diameter. It holds almost 30,000 gallons of liquid. Unless you think that the shell is thin, it's actually almost half an inch thick.
It's the biggest single prop ever used on Mythbusters. Weighing in at 67,000 pounds, made from cold rolled steel, it seems impossible that it could crush like a tin can. To check its interior integrity, Adam pulls the short straw.
This is not for people who don't like confined spaces.
You might think that crawling into one of these tank cars is a simple matter, but they transport all manner of different fluids and liquids, which means there can be all manner of different gases in that tank car that could asphyxiate you.
Oh, man. You have no idea how hot it is in here.
There's an entire set of safety procedures we had to review before climbing down in there. I'm wearing a safety harness lest I become unconscious so I can be pulled back out.
The walls are 101 degrees.
A quick recce, and Adam's nervous, but satisfied.
It's just a shell. There's no internal gusseting at all. And I'm talking quietly because this thing is a freaking echo chamber. If someone dropped a wrench up there, I feel like my eardrums would bleed.
So what I'm seeing here is 6 openings from the inside of this tanker to the outside world that we have to make sure are totally sealed to make this work. I think that's all I need to learn down here, and because it's hot as Hades, I'm gonna get back out. See ya.
It's loud, but sound. Too sound.
Oh man.
To ensure they can form a pressure vessel, the team bypasses the safety features by sealing the release valves. What's next?
Remember, this myth is about heating the tank car up, and then it happens to rain and cools it down. So this thing right here is called a monitor, and it's a spray nozzle. We're going to try to adjust the angle and the pressure in such a way, more this way, that we can get as much of an even coverage of the tank car as possible. I'm happy with that. That's a perfect rainstorm.
This is a giant production, and one of the key things we want to monitor is the temperature of our tank. Behind each one of these windows, we're going to have a thermometer. That thermometer will go to a wire, which will go out there to the tank car, where it will be attached to a thermocouple. Let's hook it up. Cool!
In addition to temperature, the second crucial parameter is the internal pressure.
This is officially the biggest thing I've ever drilled into.
Adam plumbs the steel wall and inserts a vacuum gauge.
We just turned this tank car into an experimental vessel.
And it's primed for the first step of the test. The colossal steam cleaner is fired up, and Adam is struggling to take it all in.
I'm having one of those moments right now, rabid excitement about what is about to take place. At the same time, it's combined with a complete disbelief about what we've got set up here. I mean, look at this. We've locked down 2.5 miles of train track, a mile of road. We've got about 35 guys and 1, 2, 3, 4, 5, a dozen trucks to support the implosion of that giant 70-foot-long tanker car. This is gonna be cool.
So this myth starts with the lonely train car that's just delivered its payload, and it's sitting here on the tracks waiting to be cleaned.
The cleaning comes in the form of steam. Go ahead and open up the valve and start putting steam in the tank.
Valve opening.
Piping hot at over 300 degrees, its goal is to remove every last trace of residue from the previous cargo. It's happening.
Yeah, it's already rising. Unfortunately, once the service guys had done their job, they closed every hatch and valve on the tank car, something they should never have done.
This is gonna take a while.
Yeah, a lot of mass to heat up.
Yeah. Even more unfortunately, it then begins to rain, and the completely sealed tank car full of highly expanded steam begins cooling rapidly, precipitously dropping the interior pressure.
And then what happens next is the whole tank car collapses in on itself.
Now, is that going to happen when we replicate all of those story points? We don't know. That's why we're testing it. But we will be monitoring everything from the safety of our bunker here. Well, we've been heating our tank car now for about 3 hours, and its temperature has been steadily rising, and it's very close to our small-scale temperature of over 200 degrees. That's great. Any minute now, we're going to call it. I'm going to suit up. I'll cap it, get the heck out of its way, and hopefully we'll watch it crush itself. Here we go. This is it. I gotta climb on top of that thing. It's almost 210 degrees. Shut the top manway, then I shut the bottom valve.
Adam enters the exclusion zone alone and climbs the boiling hot steel. He has to be fast and careful while he creates a 60-ton pressure vessel.
Okay, we're sealed up here. I'm climbing down.
I'm closing the valve now. Valve is closed. I am de-assing the area.
Mission accomplished. It's capped, and the countdown to catastrophe begins.
That went smoothly. Once I get back in the bunker, it's gonna be time to make it rain.
Yep, when things cool down, everything is right on track for the mythical implosion.
All right, fire department, let's make it rain.
Copy, making it rain.
Looks like is it hitting it?
It's hitting it on the far side. I think it must have gotten budged because there's
I
no
can
wind.
adjust it. So our water isn't fully hitting the tank car. I'm gonna go adjust it a little bit.
This experiment is proving to be not just the biggest, but also one of the trickiest.
This is the kind of thing that we don't want to happen. We want to see this tank collapse, and if anything is wrong, that means we have to get close to the tank to fix it, and that's bad.
Better from my end, Jamie. How about you?
Works for me. Check the kinks in the hose behind you.
Hose looks good.
Adam completes the readjustment, and back at mission control, they're all set for catastrophe.
Perfect.
It's been a monumental effort,
All right, fire department, let's make it rain.
but the team finally has all the many parts of this mythical freight train mishap in place. Cue the physics.
5 inches of mercury. 6.
Nice. It's climbing steadily. That's what we wanted to see.
The rain cools the steel. The steam inside begins to condense, and the negative pressure rises.
That is climbing a lot faster than our small scale.
The small scale car crushed at 11 inches, the single oil drum at 17. But a full-scale tank car implosion has never been recorded. The Mythbusters are once again in unknown scientific territory.
12 and a half.
Oh, I'm psyched.
The pressure differential
13.
means there is already more than 1.5 million pounds of pressure pushing on the exterior surface.
Man, that makes me nervous. That thing's so friggin' big.
I know.
And it keeps on rising.
17 and a half. We've now exceeded our small scale pressures.
It's ramping up, just like the suspense.
Come on, baby.
19 and a half.
And the tension.
21.
Wow. Man.
It's nerve-wracking.
It is, and I know that the moment I blink, it's gonna happen.
23.
Damn!
25 and a half.
Holy
15 minutes after sealing in the steam, the negative internal pressure is almost as low as it can possibly go.
26 and a quarter degrees is almost a full vacuum. That occurs at just under 30 inches of mercury.
And still there's no sign of an implosion.
Boy, they make these things tough, don't they?
As the minutes tick by,
This is killing me. We're at 18 and a half minutes.
the negative pressure plateaus.
26 and 5/8.
And for the first time, the guys think the tank car might not collapse.
Remember, folks, science can be boring.
Look, everything is working here exactly as we planned. Our methodology is dead on the money. It's not working. We got a superheated tanker that was steam cleaned that we've now been raining on, and the pressure is built far beyond what I would have considered to be a fatal, catastrophic pressure to this tanker car, and yet it's holding on at 27 inches of mercury. This is astonishing. This is a very durable item.
It hasn't budged. Okay, folks, we're gonna wait for it to be an even hour. And if we haven't seen any movement on the needle by then, we'll call it.
The pressure leveled off at 27 and hasn't budged, and neither has the tank car. So when they hit the hour,
Here we go.
they reluctantly concede defeat. Pull the plug and let the air back in.
Hey, nice work on the rig. Everything we did worked beautifully, but you wouldn't break.
It's not our fault. Technically, what we did to this car to try and make it collapse with a vacuum was flawless.
Oh, it's like the train car is peeing on me out of spite.
Got the tank really hot, We sealed it up really well. We pulled darn near a perfect vacuum on it, and yet nothing we did to it made it collapse. So it turns out these cars are actually built pretty darn good, but you know what? We're not done yet.
We've gotten back on the phone. We've ordered another tank car, as if the first one wasn't difficult enough. Now, why are we going to such extreme lengths here? It's because despite evidence to the contrary, we don't think this myth is busted yet. Look, the car that mythically imploded might have been damaged in some way that we couldn't see. It might have been corroded on the inside, some way in which it was made more susceptible to crumpling.
So we found another one, and although it'll take us all night, for you, it'll be a matter of seconds.
Yeah, let's crush some stuff.
With their more corroded car in place, they're removing the steam and rain from the equation and taking a shortcut to pulling the pressure.
This time around, though, we're going to use this big-ass industrial vacuum. It'll pull exactly the same vacuum that we got with the steam.
Is there anything duct tape can't do?
But it's going to do it in a fraction of the time.
Yep, the goal is to match the realistic negative pressure achieved using condensed steam with this giant vacuum cleaner.
All right, so you ready?
I'm ready.
All right, so we have our second, more decrepit tanker car sitting over there on the track, and our giant vacuum pump is just starting up now. That is a beautiful piece of equipment. It's going to pull a vacuum. It's going to pull the same exact vacuum we pulled with the boilers and the pressure and the cooling, etc. I do not want to take my eyes off of it. Just want to watch it do its thing. Except it should do it in a fraction of the time. I want implosion.
There's hoping.
That's what I want.
The giant vacuum pump is fast. It's rapidly removing air. And after just a few minutes, it's already approaching the maximum negative pressure it can pull.
We got a negative 25.
Negative 25.
Will the more corroded drum succumb?
Only at 27.
Holding at 27 inches of mercury. That's exactly where we were yesterday.
Yeah.
It's been a long and winding train track.
But you wouldn't break!
And the team is about to find out once and for all if a steam cleaning accident can cause a giant steel tank car to crush. They've reached the same negative pressure they managed with steam.
Holding at 27 inches of mercury.
And several million pounds of force are pushing against the half-inch thick steel, squeezing, squashing, and pressing. But the minutes tick by, and it remains resolutely intact.
27.
Still holding at 27.
Unlike their small scale, it may not be imploding, but it is an astonishing result.
You know, as frustrating as this is to not see the train car collapse, this is looking like it's a very valid myth because everybody that we talked to swore up and down that, oh, no problem, this thing's going to collapse.
That's it. That's an hour. Let's cut it.
Turn it off.
Copy.
So it just goes to show you got to test things.
That's the sound of disappointment, ladies and gentlemen.
These tank cars are actually pretty tough little bastards. But as always, we have one more trick up our sleeve.
Yep, this has been such an ordeal. There is no way we are just going to leave it here. We are now going to arrange for our tanker car to encounter a bit of a, shall we say, accident. All we need is a crane to drop something big and heavy on our tanker car. And luckily, it turns out that the sheriff who's been helping us out has access to a crane.
That is how we roll.
So we're going to use that to lift this about 30 feet above that. And then we're going to drop it. Hopefully, it'll leave a nice big dent in our tank car. And then when we pull a vacuum on it, that dent will cause the whole thing to buckle up, kind of like pulling a single card out of a house of cards. At least that's what we hope.
Yep, it's an extremely unlikely series of events, but it is possible.
That looks good to me, Jamie.
After their simulated collision, they'll pull a final vacuum to recreate the steam cleaning and see if that causes a crumple.
This is intense. Dropping 3,200 pounds on a tank car. Something we didn't expect to be doing in this episode. 3, 2, 1.
Bullseye.
Yeah! That's ideal.
Look, I can see something like this happening naturally on a train yard. A telephone pole falls over.
Well, or the equivalent of it in interior wear. And the fact is that they do put corrosive chemicals and things in these things, and it can erode.
I can't hold it in any longer. Here's the thing, right? We dropped this concrete block, and then we thought, oh, we gotta clean up all the concrete, right? We gotta clean the concrete off the track, et cetera, because there's gonna be big chunks of it everywhere. No, come here, look at this. Come here. It landed precisely, exactly where we picked it up from, upright, ready to be picked up again. That's a very respectful concrete block. That's the most cooperative big thing we've ever dropped.
Yeah, and it landed exactly, it did exactly what I wanted it to do.
Yeah, this is great.
With their completely accidental damage done, it's deja vu all over again.
All right, Dean, go ahead and start the vacuum.
The vacuum pump fires up, starts sucking, and the pressure plunges. Will the kink in the steel compromise the structural integrity?
I'm gonna say the denting compromised it. I'm gonna guess 17 inches of mercury is where it fails.
I don't know, I'm detecting a pattern here.
You're gonna say nothing at all?
Uh-huh.
That's probably the safe money. What did I say, 17? 17. Can I get a 17? Anyone wanna give me action? Cool.
10 minutes, 21 inches of mercury.
That is a hell of a vacuum pump right there.
Yeah.
It's also a hell of a dent. It's a perfect dent we made.
Yeah.
23 inches. Come on. Come on, you melon farmer.
Finally.
Oh, 23 inches of mercury. Holy cow.
This is all about the geometry. Just like with a chicken's egg, it's really quite strong and you can't break them in your hand if you squeeze them. But all it takes is one little crack on the side of the frying pan and you've got a dent, just like what we put in this tank car, and the whole thing unravels.
Man, look at that. That is beautiful.
I've never seen anything quite like that. Something that large and sturdy being deformed like that. It's kind of hard to take it in.
Really is.
It doesn't seem right somehow.
I'm getting a kind of a scale vertigo.
Yeah, yeah.
We had pulled a nearly full vacuum on two 67-foot-long tank cars and achieved bupkis, nothing. In desperation, we dropped a 3,200-pound concrete block on it and left a huge dent. Not a recommended technique for proper care and feeding of a tank car, and yet it seemed to do the trick because at 23 inches of mercury, that tank car folded like Jamie's proverbial house of cards, like this. Here, wait, play my sound effect over the actual thing. Watch this. Just like that. It was beautiful.
It looks like a big plastic bag that got deflated or something, but it's friggin' thick steel. And for it to do that, it's physics.
They finally got the implosion they were looking for. But they had to stack the deck so far in favor of a failure, this one's going to be difficult to call.
Well, this one was a bear. How do you want to call it?
Well, I think the myth as stated, we have to conclude based on the evidence that it's busted. Your average tank car, even under an impressive amount of vacuum pressure, isn't going to implode.
Agreed, but if it's dented or corroded or otherwise compromised, it could happen.
Spectacularly so. Okay, let's get the hell out of here.
Okay. We need one of those pumper cars.
Yes, I totally want one.